This question says, if possible, determine the inverse of the following. First one I have is f of x equals 3x minus 7. Now, what must be true for a function to have an inverse? It has to be 1-to-1. It has to pass the vertical line test. So I'd like to take a look at that and see if that's the case. Can I identify the graph of that function? What does it look like? And then can I go ahead and determine whether or not it's 1-to-1? So let's pull up Desmos. So I've got the function f of x is 3x minus 7. And sure enough, it's a line. The slope is 3, rise 3, run 1, rise 3, run 1. Y-intercept is -7. So no surprise, any horizontal line, for example, y equals -2, intersects it at exactly 1 point, not more than 1. So if that's the case, the function is 1-to-1. So it does have an inverse. Now, how do we find that inverse? Well, we'll do it algebraically, but I want you to think about it for a minute. Take a number, multiply it by 3, and then subtract 7. That's our order of operations. Take a number, multiply it by 3, and then subtract 7. How would you reverse that process? What would you do first? What would you do second? So think about that. But here's my algebraic approach. I will say y equals 3x minus 7. And the point of an inverse is x becomes y, y becomes x. So this becomes x equals 3y minus 7. And I've got to solve for y. So let's add 7 to both sides. So x plus 7 is 3y. Divide by 3, divide by 3. So I have x plus 7 over 3 as y. And that should be my formula for f inverse. So f inverse of x should be x plus 7 over 3. Now we could take the composition f circle f inverse or f inverse circle f and see if the result really is x. There's another way we can check that. So going back to Desmos here, we've got 3x minus 7 there, and then what I think is f inverse, I'm going to just call g here, is x plus 7 over 3. And what do we know about inverses? They are supposed to be mirror images along the line y equals x. So there's the line y equals x. The black function is f of x, that's 3x minus 7. The blue function is g of x, is x plus 7 over 3. Do they look like mirror images across this green line y equals x? I think so, right? We have this one 2.3330. Here we have 0, 2.333, right? 5, 4, and 4, 5. So indeed, we have a mirror image, so what we have is correct. That is the inverse. All right, so for our next example, we want to find the inverse of g of x is x minus 3 over 2x plus 9, if it's possible. But let's check to make sure that's 1-to-1. Let's at least look at a graph and see if any horizontal lines would cut it in 2 points. So we've got that function g of x equals x minus 3 divided by 2x plus 9. And what do you think? Does it ever bend back on itself? We have some kind of asymptotic behavior here. So it looks almost horizontal, but the fact of the matter is it's getting closer and closer to 1/2 the horizontal asymptote without ever actually getting there. So yes, this is a 1-to-1 function, and we can't find its inverse. So how do we do that? Well, first of all, I rewrite it as y equals x minus 3 over 2x plus 9. And then what do I say? I want it to be an inverse, so x becomes y, y becomes x, and then I solve for y. So y becomes x equals y minus 3 over 2y plus 9. The algebra here gets a little interesting. So let's work through that. X equals y minus 3 over 2y plus 9. And our goal is to solve for y. So the first thing I'm going to do is I'm going to multiply both sides by the common denominator, which is 2y plus 9. Multiply the left side by 2y plus 9. Multiply the right side by 2y plus 9. And on the right side, you'll see that it divides out. That 2y plus 9 over 1, 2y plus 9, that goes away. And on the right side, I have y minus 3. On the left side, I have x times 2y, which is 2xy, plus x times 9 is 9x. Now remember, our goal is to solve for y. So I need all the y's on one side, all of the non-y's on the other. So let's go ahead and subtract y from both sides. It'll get all the y's on the left when that goes away. And I have to get rid of the 9x, so let's subtract 9x from both sides, so that this goes away. Now we are left with 2xy minus y equals negative 3 minus 9x. Let's factor out that y. Y gets factored out. And I have 2x minus 1 equals negative 3 minus 9x. And let's divide out what's multiplying y. What's multiplying y is 2x minus 1. So we have solved for y. That was our goal. Y equals negative 3 minus 9x over 2x minus 1. And that should be my F inverse of x. Or excuse me, G, I believe, was the letter we used here. So G inverse of x should be negative 3 minus 9x over 2x minus 1. Let's see if that is the case. Let's take a look at Desmos again. So I have G of x there, which is that purple graph. And I'm going to draw G inverse, which again, I'm just going to call h of x. Oops. Which is going to equal what? Oops, that's a mistake. H of x is going to equal negative 3 minus 9x divided by 2x minus 1. And we hope that those graphs are mirror images with respect to the line y equals x. And it sure kind of looks that way. You see the mirror images here for the purple part, which is G, and the black part, which is G inverse. Purple part, which is G over here, black part, which is G inverse. So that looks pretty good. There's one other way that I can check this. So we have what we think is the graph of G. Which is G inverse, and I'm going to rewrite G in terms of y instead of calling it G. So those are still the same two graphs. And now to get the graph of G inverse, x becomes y, y becomes x, right? So x equals y minus 3 divided by 2y plus 9. And we hope this graph is the same as the black graph. Let's change that color so we can see it better. Oops. And make it red. Now, if I turn the red off, is the red is the same as H? Sure is. So red and H, which is G inverse, are the same. So that's another indication that we've done this correctly.